The distribution of the size of claims under insurance policy has PDF Cx power a, x between 0 and 5. For a randomly selected claim, the probability that the size of the claim is less than 3.75 is 0.4871. Calculate the probability that the size of a randomly selected claim is greater than 4. So we will use two conditions to find the two constants C and A. One condition is this one, that the probability that the claim size is less than 3.75 is 0.4871. So let's do this and then I'll mention the second condition. So probability X is less than 3.75 is equal to 0.4871. So 0.4871 is equal to probability X is less than 3.75, but that by definition is integral from negative infinity to 3.75 of the PDF. And the PDF is only defined for X between, is only non-zero for X between 0 and 5. Remember, we repeatedly use this convention that we write it only in the part where it's non-zero and it's understood that it's 0 everywhere else. So it's Cx to the A when X is between 0 and 5. So it means you don't start from negative infinity, you start from 0 and you get Cx to the A. And the integral of X to the A is X to the A plus 1 over A plus 1. C is a constant that's kept. And when you substitute, so I bring the A plus 1 on the left, so it multiplies here. And I keep the C here. So the reason I'm doing this is to just clear the fractions. C is a constant, so that's kept out. And then we substitute 3.75 power A plus 1. So 3.75 goes in for X and the lower limit is 0. So 0 power anything is 0. And this is our equation number 1. And now the second condition that we're going to use is the fact that the integral of a PDF over its entire range is 1. So this was the PDF, Cx to the A, and its non-zero range was 0 to 5. And that integral is equal to 1. And once again, we integrate. And again, I bring the A plus 1 to the left to clear the fractions. And this time I get C times 5 power A plus 1. So that's equation 2. So if I divide 1 by 2, remember 1 was here. So I divide this by 2. The A plus 1 will cancel out. So I get 0.4871. Right, 0.4871 times A plus 1. When it's divided by A plus 1, I just get 0.4871. And the C's cancel out on the right-hand side. And the right-hand side of 1 was 3.75 power A plus 1, and of 2 was 5. I mean, C times 3.75 A plus 1, and this was C times 5 to the A plus 1. So it's the C's cancel out, and it's 3.75 over 5 power A plus 1. And this is equal to 0.75 power A plus 1. And then I take ln of both sides, and I get A plus 1 to be 2.5 when I divide both sides by ln 0.75. And then when I subtract 1, A is 1.5. So I can substitute the A plus 1 in 2. A plus 1 was 2.5 from here. So I get 2.5 equals C 5 power 2.5. And well, if I multiply both sides by 5 power negative 2.5, I get C equals 0.0447. So now I have both the constants in the PDF. Remember, fx was Cxa, Cx power A, so C is 0.0447, and A was 1.5. So this is the PDF, 0.0447 x power 1.5. And we wanted probability of that the size of a randomly selected claim is greater than 4. So probability X greater than 4. So greater than 4 means 4 to infinity, but it doesn't go all the way up to infinity. It just ends at 5. So 4 to 5 of the PDF. And when we integrate this, 0.0447 is a constant. And the integral of x power 1.5 by the power rule is x power 2.5 over 2.5. So limits are 4 to 5. And when we substitute the limits and do the calculation, we get 0.428. That was choice B.